Introduction to Limits Part 2. In a previous video, I introduced the concept of a limit. So real briefly, when we're looking at the limit of a function, we're looking at how the y value is changing or what the y value is approaching as x approaches some number. So let's do a real quick review right here. So in this particular graph, and we'll say that this is the function f of x. And we want to know what is the limit as x approaches -1. So we're looking for the limit as x approaches -1 of the function f of x. And so we can move along this line coming from the left-hand side from smaller values. And as x approaches -1, we can see that the y value or the function value is approaching what it looks like to be -1.5. And so we would say that the limit of the function as x approaches -1 is -1.5 as we are coming from the left. And as we're coming from the right, we're also seeing that the limit of the function as x is approaching -1 is also -1.5. They're approaching the same value, which is this value right here. Now, it also happens to be true that the function value, f of -1, is also equal to -1.5. They are all exactly the same. Now, what I did not do in the previous video that I'm going to do now is I'm going to be a little more specific. And as we are approaching the x value from the left, I'm going to call that a left-hand limit. So right here, we were approaching from the left. So this is a left-hand limit. And to show you that this is a left-hand limit, I'm going to put a little minus sign right up here. That means we're approaching from a negative value or from the left. And we also want to approach it from the right, which would be coming down this way, from larger values of x on the x-axis. We're going to call that a right-hand limit. And so to show you that this is a right-hand limit, I'm going to put a little plus up here to show you that it's coming from positive directions on the x-axis over here. So this would be a left-hand limit. And this would be a right-hand limit. Now, in order for there to actually be a limit at a point, as x is approaching a point, the left-hand limit and the right-hand limit have to be the same. And they clearly are. The left-hand limit here, the left-hand limit is -1.5. The right-hand limit is -1.5. So therefore, we could say that the limit of the function is -1.5. Now, a lot of students at this point get confused because they say, well, what's the difference between the limit and the function value? And as I stated in the previous video, sometimes they are exactly the same, as in this particular case. The limit and the function value are the same. But here's a case where they are not. And so let's take a look at the left-hand limit. And so the left-hand limit would be the limit of this function, we'll call it f of x again, as x approaches, and let's make it x approaching 2. As x approaches 2 from the left, this would be the left-hand limit. So in other words, we're approaching along this line right here. We're coming along this way, getting closer and closer and closer and closer to 2. Well, it appears that the function value or the y value is approaching -3. All right, now let's find, this would be the left-hand limit. Left-hand limit, LHL. And now the limit of the function as x approaches 2, but from the right, this would be the right-hand limit. That means we're coming along this direction. Well, the function value is also approaching -3. So the right-hand limit is -3. They're approaching the same value, -3, in either direction. So therefore, what I can say is that the limit of the function as x approaches 2, not from the left, not from the right, but from either direction, is equal to -3. This is the limit. Okay. This is a left-hand limit coming from the left. We have a right-hand limit coming from the right. And if those two are exactly the same, which they are, then we just say that the limit is -3 in this case. But notice that that's different than the function value. The function value is down here. This is where there's a hole in the graph, which means nothing exists there. Let me get rid of some of this stuff here. Okay, why is there a hole right here? Well, there's a hole right there because nothing's there. It's emptiness. So the function value at 2 does not exist at this point right here at -3. The function value exists down there. They've moved it. Why? I don't know. Doesn't really matter right now. But the function value is at -4. So we would say that the function value f of 2, function value at 2, is equal to -4. Well, notice that this is not the same as the limit. So in this particular case, because we have a hole in the graph, the function value is not the same as the limit. So this is where we start to really see the importance in understanding the difference between a limit, which is what the function is approaching as we approach a number, and the function value, which is what the function is equal to at a number. Okay, here's another example. So now, if we find the limit of this function as x approaches, let's use -1, and as we approach it from the left, we are approaching this function value, which is -2. But as we approach the x equals -1 from the right, that would be coming over this way, coming along the line. Now we're approaching -1. So the graph is approaching -2 from the left. It's approaching -1 from the right. So because these are different, the limit does not exist. The limit of the function as x approaches -1 does not exist. Okay, the left-hand limit exists. So let me write this a little bit differently. The left-hand limit does exist. This is the left-hand limit. This is the right-hand limit. But they are not the same. They're different. So therefore, the limit does not exist. In order for the limit to exist, the left-hand limit must be equal to the right-hand limit. Well, what about the function value? Well, the function value is way up here. So the function value, f of -1, is equal to 3. So the function value is 3. The left-hand limit is -2. The right-hand limit is -1. The limit doesn't exist at all. And finally, let's kind of put it all together and look at this fancy little graph. Let's start off by looking at 1 right here. What is the limit as x approaches 1 from the left. Well, as we approach 1 from the left, we come along here, come along this piece of the line, and the y value that it's approaching is 4. But the limit as x approaches 1 from the right, okay, so we're approaching 1 from the right, we would come along this line, we're coming down this way, we're getting closer and closer to 1. So does the limit at 1 exist? What is the limit as x approaches 1? It does not exist. Okay, why? Because the left-hand limit, which is this, and the right-hand limit, which is this, are different. So the limit does not exist. When the left-hand limit and the right-hand limit are different, you're going to have what's called a gap. And you can see we have this gap in here, this vertical gap or break between this part of the graph and this part of the graph. Well, let's take a look at, let's take a look at 5. Now, what is the limit? The limit of this function as x approaches 5. Not from the left, not from the right, but just the general overall limit. Well, to answer that, we have to say, well, what's it approaching from the left? From the left, we're approaching 2. And to the right, we're approaching 2. So even though I'm not writing it out, I'm not writing out the left-hand limit and the right-hand limit, I'm doing it mentally. I'm seeing that this is approaching 2 from both directions. So therefore, the limit is equal to 2. Now notice that there's a hole in the graph here. So the function value is down here. The function value at 5 is equal to 1. All right. Now take a look on your own at some of these other points, such as 3. What is the limit as x approaches 3? And what about, let's say, 4? What is the limit as x approaches 4? Take a moment and think about that. Okay. As we approach 3 from the left, the function value is 3. As we approach x equals 3 from the right, the function value is 2. So the left-hand limit is 3, the right-hand limit is 2, therefore the limit does not exist. And the function value at 3 is defined where the closed circle is, so the function value at 3 is also 2. What about 4? As x approaches 4 from the left, the function value is approaching 1, so the left-hand limit as x approaches 4 is 1. The right-hand limit as x approaches 4, it's approaching 3. So the left-hand limit is 3. The right-hand limit is 3. The left-hand limit is 1. There is a gap here. That means the limit as x approaches 4 does not exist. And what is the function value at 4? It's up here at 5. So f of 4 would be equal to 5.